Hi class. Hi class. This video is the lecture notes for Monday, August 31st. We're talking about standard apparatus and Bunsen burners today. So what you see on your screen now is a picture of what our standard apparatus looks like. This, you'll see we have a pole here in the middle. There's a base, and there's these two rings on it. This here is a little bit of wire gauze, and then our Bunsen burner. So I want to show you one here, a real life one here real quick, and then we will go through and fill out this slide. So hopefully you can see, if I turn this a little bit too, you can see that there is a ring, a smaller ring here and a bigger ring right above it. Those are attached to our ring stand. So I'm going to swing these back so they're above each other. I'm going to take my wire mesh. I'm going to put it on the lower ring stand. I'm going to take my beaker, put it in on top of that wire mesh. Now notice where I have the upper ring. I don't have it all the way up here because then you can't grab it with your beaker tongs. It's really hard to grab with your beaker tongs. So make sure this is a little ways down, enough that you can easily grab your beaker. Okay. So we'll have our little ring on the bottom with our wire gauze, our beaker inside, and then our big ring on top. Next thing you need is your Bunsen burner. All right. So back to our notes here on the presentation. If you look at it here, I've listed those parts: the ring stand, the wire gauze, beaker, small ring, large ring, and the Bunsen burner. So let's put those up on the screen. I got the arrows for the ring stand. Please label your notes that that's the ring stand, that base, and the bar. And that it's kind of hard, might be hard to see the wire gauze, but if you look at it, it's kind of fuzzy there on the top of that smaller ring on the bottom. That's our wire gauze, and we use that to distribute the heat from our Bunsen burner when we heat up our beaker, right? Above the beaker then, below the beaker then is that small ring support, because that we want it small enough that the beaker won't fall through it. It'll give support of the wire gauze. While above it is our large ring support, so we can handle a bigger size beaker than maybe our little ring could support. But it won't bounce off. It's to hold it from bouncing off. All right. Now, if you see in my notes here, it says it goes the large ring, the big ring goes about halfway down the beaker. I'd put just not quite halfway down, a little bit more above halfway. I don't want it down here, but I want it low enough that it's going to keep this from bouncing out and that you can reach and easily grab it with your beaker tongs. Now, that's what I just kind of mentioned there. I want you to use your beaker tongs when we pull things out. So our Bunsen burner there with our flame. Now, the key thing about our flame is we want it 3 fingers tall. So I don't have mine adjusted here quite right. It's too small. So I'm going to raise this ring up a little bit. And there we go. So I want to be able to fit 3 fingers between the top of my Bunsen burner and the bottom of that little ring, that small ring. 3 fingers. That'll make sense here in a moment when I explain the next piece. And finally, how do we remove our beakers? Don't forget, use your beaker tongs. This will be very hot. Do not grab it like this. You will burn your hand. Depending on how you do it, you might burn your hand pretty bad. So always remember, if we can't tell what the glass is hot or not, use your beaker tongs. All right. So now, if you notice, I'm working with a Bunsen burner. I'm going to have my goggles on. We always need to have goggles on when we are working with our Bunsen burner. It's just to keep your eyes safe. It's too easy to get hurt. Let's protect our eyes. They're very valuable, guys. So I always want to see you wearing goggles when we're working with our Bunsen burner. Next thing I want to show you here, your hair must be pulled back. Hair must be pulled back. Now, I don't have short hair, but if you had hair that was long, remember how we define long hair in chemistry class? Yeah, if you lean forward and your hair falls forward, you got long hair. So if you got long hair, you must have it pulled back. Any loose clothing, please make sure it's secured. We don't want it to fall into our Bunsen burner flame or our chemicals that we're heating up. There are no exceptions to this. I will be very, very strict on this when we get back to school. All right, so now let's talk a little bit about a Bunsen burner. So I'm going to move my standard apparatus up here a little bit. And what I want you to see is we're going to have a Bunsen burner. We got a spark igniter, right? And now what we're going to do is we're going to practice lighting them. So I want to show you what we're doing. Now, if you look at the picture of the Bunsen burner I have there, it says label where you control oxygen and gas flow. This valve here at the bottom, down here, if I show it to you from the bottom, this controls our gas flow. You can turn the gas off to your Bunsen burner or on. And it's adjusting it. So is it a little bit of get off, a little bit more, a little bit more, a little bit more, a little bit more. Right? So that's how we're going to control the gas flow through our Bunsen burner. Right? On the top here, we have this kind of rod that is the top. This also screws up and down. And if you screw it up and down, you can see what I'm going to do is I'm going to open up a little window down here. Right? Hopefully you can see that. There's a window down here in this bottom part. That lets oxygen in so that our flame can burn. When this is totally closed, no oxygen's getting in here. Okay? So those are the two ways we control the flame. Now, if you remember at all, or if you've been taught how to do this, lockwise is clockwise. So that means if you're looking down on something, if I'm looking down on the top of this, if I spin it lockwise, I'm closing it down. So that means I'm going to shut this down. If I spin it clockwise, we're opening it. And you'll see that this goes up and up and up, and then we eventually get the little window here at the bottom. Now, the same thing happens for the screw in the bottom, but let's think about that for a moment. That screw is on the bottom facing up. So it's going to be opposite for you. While we turn the top barrel clockwise to tighten it, we have to turn this knob on the bottom counterclockwise. If you're looking at the top, you're going to turn it counterclockwise to tighten it. So it might get a little confusing at first, but once you get some practice, you'll get used to it. All right. So that's how we're going to label where our oxygen and our gas flow is. Right? The gas flow controller, so the tube comes in, our gas flow controller is at the bottom. And then we have our air coming in through this little gap right here. Does anybody know what the gas is that we're using? Does anybody know what the gas is that we're using? Well, hopefully some of you know it's called natural gas, because that's the common name for it. In chemistry, we call it methane. Methane. And we'll learn about methane a little bit later in the year when we start talking about hydrocarbons and naming them. This is a very simple methane, and it burns very readily. How do we know that the gas is on and flowing? Well, you'll hear it. You should be able to see on the side over here, there's the gas valve on top of our lab table. When you turn this valve, this is either on or off. Right? I don't want you turning the valve halfway. If it's perpendicular to the hose, it's off. If it's parallel to the hose, it is on. Don't put it part way. I never want to see it part way. You do not use this to control how much gas. It's either on or off. So now I've got my gas on. How do we know that it's on and flowing? Well, you'll hear it actually from the top. Right? So we got the valve parallel with the tubing, and you'll hear the gas coming out the top. If it doesn't, that means you've got your fuel valve turned too low on your Bunsen burner, and you're going to have to open it up a little bit. But you should very easily hear that gas. All right, so now let's talk about what's the equation. What's our chemical equation that we're doing here? So if you look at this, right, so the parallel are on, and perpendicular means it is off. Our chemical equation here, I'm going to write this in chemical symbols and words. We'll learn this later on in the year as well. But we're going to use methane, that's our gas, and we're going to react it with oxygen. So we're at methane plus oxygen. This little arrow here in the middle, that means that you see it's pointing one way. That means our reaction only can go one way. We're going to take that methane and mix it with oxygen. We give it a little bit of heat, and it's going to burn. And when it burns, what does it turn into? It's going to create water and carbon dioxide, both things that we are very used to, that our bodies need water, and we exhale carbon dioxide. So nothing there is harmful to us. Now, how do we do this in chemical terms? Well, we'll learn later. The chemical name for methane is CH4. That's one carbon and four hydrogens. Oxygen comes as O2. That means there's two oxygens. There are several elements, usually, and almost all of them are gases, where they come in pairs. They don't come by the single element itself, so they always come in pairs. O2 is one of them. And we're going to react those two, and they're going to create water, H2O. Hope you guys have heard that phrase before. And then they're also going to create carbon dioxide, CO2, another name that hopefully those chemical symbols sound somewhat familiar to you. You've heard of H2O and CO2. Okay. So now that we've got one more thing, I'll teach you this later on in the year as well. We need to balance this equation. So if you see, I've put a 2 in front of the O2 and a 2 in front of the two H2Os, in front of the H2Os. That means to balance this equation so it works right, we need 2 oxygen molecules on the left and we're going to get 2 water molecules on the right. Now, the key thing I want you to see here is if you look at the left, we only have 1 methane, 1 CH4, but we need 2 oxygens. 2 oxygens. In other words, if we want that perfect flame, we want to get the hottest flame possible, we need to have 1 part gas to 2 parts oxygen. Okay? So how are we going to know that we got that perfect ratio? That's what I'm going to show you here next. We're going to look at the type of flame that comes out of our Bunsen burner. So I'm going to turn my gas handle here at the desk to parallel. My gas is on. I can hear it coming out of my Bunsen burner, so I know I've got the valve down here in the bottom open. And I'm going to take my handy dandy spark igniter, and I'm going to put it above my flame. Now, let's see, I got to close. If I have this closed all the way, screwed all the way down, you see I have a nice yellow flame here. Nice yellow flame. We call that a birthday candle flame, right? Why do we call it a birthday candle flame? Well, whenever you look at a birthday candle, a birthday cake, you got this nice big yellow flame, right? Nice big yellow flame. So what does that tell us? Well, I kind of hinted at it a moment ago that I've turned the air valve down, so there's no oxygen coming in here at all. So while we're burning this methane, it does not get enough oxygen. It does not get enough oxygen. Now, this flame's not hot. I can hold my hand up here. I can feel it's warm, but it's not going to burn me. Now, yeah, if I put my hand on the flame, it would burn me. But if I put my hand above here, it's not going to burn me. It's not hot. It needs more oxygen. We don't have the right ratio of methane to oxygen to get a nice flame. So now I'm going to open up my barrel here on the top. I'm going to screw it counterclockwise because I want to open it. And while we're opening it, you're just going to see the flame's going to change because I'm now letting a little bit of oxygen in. Right? And now what we see here, the flame's slowly going to turn, so we just have a blue flame. That might be hard to see, so let me go turn off my lights. So hopefully you can see a blue flame. I'm not sure how well my camera picks that up in the low light situation, but we have this nice big, we call this our big blue flame, our big blue flame. So if you look at it, it's a nice blue flame, a little bit of yellow at the top. If I still give it a little bit more oxygen, I can get that yellow to finally disappear. There we go, that's a little bit better. Nice blue flame. We move and see if I get different backgrounds, whether you can see that better. All right, so what do we know about this flame? So we've given it a little bit more oxygen, right? Now our flame is blue. It's not that yellowish orange that it was before. And this is hotter. If I hold my hand up here, notice I can't get as close as I was before. It's hot. I can start to feel it, right? So this one's a little bit hotter. We're getting closer to that right ratio of one methane to 2 oxygen molecules, but it's still not hot enough, right? We don't have quite that perfect ratio, so it's not going to be as hot as it can be. So on to our next flame. You look at this picture. What's the difference between these 2 pictures? Well, the one I just put in the bottom right, it looks like there's 2 flames. There's kind of an outer blue flame that's a little bit darker, not quite as bright. And there's this brighter blue inner flame that's also lighter in color. So it's much more intense and a little bit lighter in color. So I'm going to adjust my oxygen valve. I'm going to keep opening it up, giving it more and more oxygen. More oxygen, more oxygen, and you're going to notice that this blue flame is going to start to change. We're going to see less and less of the yellow until it's finally gone. And now you're going to start to see inside the middle of that flame, there's a little flame inside of it, that brighter blue flame, that brighter blue flame. So I'm going to keep adjusting it. So I want to get that nice, well-defined inner blue flame. I want to be careful I don't take this too far off. All right, so there we go. We have a nice, bright blue flame. Right? This is the hottest. If I hold my hand here, I can really feel it. In fact, I can't hold my hand there very long. We've got that nice, perfect mixture, 1-to-2 ratio, 1 part methane to 2 parts oxygen. Now, the last thing I want to tell you about the Bunsen burner flame, for the purpose of our chemistry class, we only want that inner blue flame to be 3 fingers tall. Now, if you see the one I have here, it's a little bit too high. Now, when do you remember me talking about 3 fingers earlier in the lecture? Well, that's when I was putting the standard apparatus together. It was 3 fingers from the top of the Bunsen burner. Whoop, a little bit of a breeze there caused my Bunsen burner to go out. There's 3 fingers from the top of my Bunsen burner to the bottom of my beaker. The hottest part of the flame is right at the tip of that inner blue flame. So it's too big, so I'm gonna have to back it off a little bit. So I'm gonna screw in my fuel valve a little bit. So we're gonna decrease the amount of gas. And now I'm gonna adjust my oxygen a little bit too, since I decreased the, whoop, we're getting enough of a draft in here. It's causing me some problems. Let's turn my valve a little bit low. Maybe I had too much gas going. These Bunsen burners are a little flaky. All right, now you see that flame. Whoa, still a little low. Yeah, these things are flaky enough that they just tend to get a little bit hard to run. All right. Let me try to get a different Bunsen burner. Some of our Bunsen burners are a little flaky. Unfortunately, I grabbed one that was a little flaky. Let's try one and see if this one's going to work better for us. Make sure I've got my valve about where I want it. We're going to turn on our gas. All right, so I have that nice big birthday candle flame. Again, I'm going to let oxygen in. So I'm going to unscrew the barrel on the top, turning it counterclockwise. Got to my big blue flame. We're going to keep going. We're going to keep going. We're going to keep going. All right, so that flame looks pretty close. Now I've got it adjusted. I've got that 3 fingers. So let's take this, and we're going to put it onto our standard apparatus. We put a little bit of water in the beaker there so I don't scorch it. Now that our Bunsen burner's lit, we're going to stick it underneath of our beaker. Now you might be able to see at this point the wire gauze is starting to glow red hot. That means it's helping diffuse that heat to heat the bottom of the beaker nicely. Now I'll take the beaker off for a moment so you can kind of see that better, hopefully. You can see where there's a little bit of yellow flame on top, but the hottest part of the flame there is right at the wire gauze. That's what's going to give us the most heat and to help heat up our liquid the fastest. All right, guys, that's all I have for you today. And come back tomorrow, and we will learn a little bit more about. Come back tomorrow. We're going to learn a little bit more about graphing. But one quick reminder, make sure you take the question quiz, the lecture question quiz at the end of today's folder. That is for 6 points. Please make sure you hit submit when you finish that quiz. All right, guys, take care. Bye-bye.